Okay, this is your week 3 recent advances in transmission insulators and course code is NOC 24EE71. I'm your teaching assistant Nida Khanam. I'm a research scholar from Department of Electrical Engineering, Aligarh Muslim University. So from last session, we have covered the types of insulators, what factors determines the insulation design, manufacturing process, design criteria, field experience with different insulators, comparative analysis, environmental issues, and their effective solutions. So today we will discuss reliability and testing of transmission insulators. So as we all know that transmission insulators are very essential component in high voltage and extra high voltage power transmission systems. So their primary function is to provide electrical insulation between live conductors and grounded structures while withstanding environmental and mechanical stresses. So basically reliability of insulators is very important for maintaining the stability and efficiency of the power grid. So insulators failure can lead to power outages, equipment damage, and safety hazards. To ensure reliable operations, insulators undergo rigorous design, material selection, and extensive testing before being deployed in the power system. Okay, so reliability and testing ensure long-term operational efficiency in harsh environments. So there are some factors which affects the insulator's reliability. These are such as electrical stress, mechanical stress, environmental stress, aging and degradations. So electrical is due to electrical stress, over voltages can occur, which leads to flashover, and also wind loads and conductor weight also causes the mechanical stress, and UV radiation, pollution, moistures also comes from environmental stress, and due to aging and degradation, insulators weaken over time due to the continuous exposure to harsh environments. So here are some details. Like in electrical stress depends on operating voltage, temporary overvoltage, lightning and switching surges, leakage current and surface tracking. So in insulators, for operating voltage, insulators must withstand continuous high voltage without degradation or breakdown. Second is temporary overvoltage. So this occur due to the load rejection, fault clearing or switching operations. It can cause partial discharge leading to gradual insulation deterioration. Now third is lightning strikes. Lightning strikes can cause high voltage transients in transmission system, and switching operations in EHV or UHV systems generates over voltages that may exceed the insulation limits. Now fourth is leakage current and surface tracking. So as we know that pollution, moisture, contaminants on the surface of insulators, it can create a conductive path which leads to flashover, and polymer insulators have hydrophobic surface that can reduce the leakage currents. Now second factor was mechanical stresses due to the wind load and vibrations. As we know that high speed winds create mechanical stresses and oscillations in insulators. For this, long transmission spans experience Aeolian vibration that can damage insulator strings. Now second is weight of the conductors. Insulators support the weight of the heavy conductor and withstand their mechanical tension. In suspension system, failure of one insulator can cause cascading failures in the network due to the weight of one conductor. It can cause the mechanical stresses. Now, third is seismic forces. Earthquake can impose dynamic forces on insulators in substations and transmission lines. Seismic resistant design ensures the system stability. Now, the third factor is environmental stresses. Environmental stresses are due to the pollution and contamination, temperature variations, UV radiation exposure. So, as we know that in industrial area or coastal areas, most of the insulators are exposed to pollution such as dust, salt, chemicals, which can lead to flashovers. So for this purpose, we will have to provide the periodic washing, cleaning, RTB silicone coatings, or some special creepage designs. Second is temperature variations. So in extreme hot and cold climates, it can cause expansion or contraction, which leads to material degradations. And third is UV radiation exposure. So in long term solar radiation occurs, then it degrades the polymeric insulators. So in that case, we will have to use the UV resistant materials and coatings, which improves the lifespan of insulators. So now there are some high voltage testing techniques of transmission insulators. As we know that the transmission insulators are subjected to various electrical stresses, mechanical stresses, and environmental stresses in real world conditions. So this test ensure their reliability, and they undergo high voltage testing based on international standards such as IEC 60383, IEC 61109, NCC 29, and IS 731. Why we are doing testing? Because by testing the insulators, it can withstand electrical stresses without flashover or breakdown. It can have sufficient mechanical strength to support the conductor loads. It also resists environmental factors like pollution, UV radiation, and temperature changes. So basically, there are four types of tests, which are categorized as type test, routine test, acceptance test, and special test. The type test is used for design verification, also known as design verification test. It is conducted on prototype samples to validate performance. Now, second is routine test. Routine test is also known as quality control test. It is performed on every insulators during production. Now, third is acceptance test. It is also known as batch sampling test. It is conducted on a batch of insulators before deployment. Now, fourth one is special test, also known as long-term performance and environmental test. It is used to simulate the real-world conditions. Now, first test is type test. Under this, there are some different categories. First is dry lightning impulse voltage test. So, by doing this test, it ensures that the insulators can withstand lightning surges without flashover or breakdown. So the main procedure is a standard lightning impulse voltage is applied to the insulators. Then voltage is increased until any flashover or puncture occurs. If the insulator must withstand the specified voltage level as per the design. So if there is no flashover, breakdown, or any damage, then insulator will pass the dry lightning impulse voltage test. Now, second is wet power frequency withstand voltage test. So, the main purpose of this test is to check the insulator under wet conditions like rain simulation condition. So, first of all, the insulator is sprayed with water at a controlled rate, and high voltage AC voltage at 50 Hz is gradually applied, and the voltage is maintained for 1 minute to check for breakdown. Okay. Now, the third test is mechanical load test. It verifies the mechanical strength of the insulators under tensile and bending loads. So, first of all, insulator is subjected to mechanical loading such as tension or bending, and load is gradually increased until the rated mechanical strength is reached. Now, fourth is temperature cycle test. The main purpose of this test is to check the insulator's ability to withstand extreme temperature variations. So, the insulator is subjected to rapid heating and cooling cycles, and temperature range depends upon the material which we are using, like ceramic, glass, or polymer. And if there are no cracks, deterioration, or material degradation, then insulator can pass temperature cycle test. Now, fifth is porosity test. Porosity test is done for ceramic insulators. It detects defects in ceramic insulators that can absorb moisture and fail in service. So, first of all, the insulator is broken into small pieces. Then the pieces are immersed in a dye solution under vacuum, And if dye enters the material, the insulators is considered porous and rejected. And if there are no absorption of dye into the material, the insulators will pass the porosity test. Now, last is radio influence voltage test, that is also known as RIV test. It ensures the insulator does not generate high frequency electrical noise that can interfere with the communication system. So for this purpose, first of all, we have to apply the high AC voltage to the insulators, and our radio interference measuring instruments records the level of electrical noise. If there are noise levels should be within acceptable limits, then insulator will pass the RIV test. Second is routine test. It is also known as manufacturing quality control test. These tests are performed on every insulators during production to ensure the quality consistency. So under this, two categories. First is visual inspection. So the insulator is checked for surface defects, cracks, and dimensional accuracy. And if there are any visible defects, that can lead to rejection. If there are no cracks, mechanical defects, or surface irregularity, then insulator will pass the visual inspection test. Now B part is electrical withstand test. So the main purpose is to ensure that the insulators can withstand its rated voltage. So first we have to give the high AC or DC voltage for a specified time, and voltage is increasing gradually to prevent the insulation breakdown. Now third test is acceptance test, also known as batch sampling test. Acceptance tests are performed on a selected sample from a batch from delivery to ensure batch quality. So in this, there are two types of tests, that is high voltage puncture test and steep front impulse voltage test. In For high voltage puncture test, it is used to ensure the electricals insulators dielectric strength. So a high voltage is applied between the metal fittings, and voltage is increased until breakdown occurs. And if breakdown voltage should be uh, above the minimum requirement, then the insulator will pass the high voltage puncture test. Second is a steep front impulse voltage test. This test is used for checking the ability of insulators to withstand sudden high voltage surges. So for this, the main procedure is to have to give the fast rising impulse voltage. Then there should also be a criteria that voltage rise time is much shorter than the standing lightning impulse test. If there are no flashover or breakdown during this, then insulator will pass the steep front impulse voltage test. Now last is a special test. A special test is for environmental and long-term performance, and in this there are categories like pollution performance test. It evaluates the insulator's performance under contaminated conditions such as salt, dust, or industrial pollution. And in this process, the procedure for this is a pollution layer is artificially applied to the insulators, and a high voltage is applied to check leakage current and flashover voltage. So again, if there are no flashover under specified pollution severity, then it will pass the pollution performance test. Otherwise, we have to perform again this test. Now B part is accelerated aging test. So it simulates the long-term exposure to ultraviolet, UV rays, and humidity and thermal cycles. So in this test, insulators are exposed to UV radiation, heat, and moisture cycles for weeks or months. Then the test checks for material degradation and hydrophobicity loss. If there are no significant material degradation, then the insulator will pass the accelerated aging test. Now, third is water diffusion test. This test is used for composite insulators, and the purpose is to check the moisture absorption tendency of polymeric insulators. So, the insulator is placed in a high humidity environment, and if what and water absorption and electrical performance are measured. And if there are minimal absorption of moisture, then insulator will pass the water diffusion test. Now, fourth one is hardness test. Hardness test is done for polymer insulators. It evaluates the strength, and durability of polymeric insulators. And the procedures are: a hardness test is performed using a durometer, and material should resist indentation and deformation. If hardness should be within the acceptable limits, then the insulator will pass the hardness test. Okay. Now, their failure modes and prevention. One second. हेलो जी आंटी, वालेकुम सलाम जी। ठीक है ठीक है ठीक है। ठीक। ठीक है, मैं ले लूंगी आंटी, ठीक। ठीक है ठीक है ठीक है जी, अल्लाह हाफिज। Sorry. So now moving on to the failure modes and prevention. So there are some failures like electrical failures, puncture failures, corona discharge, mechanical failures, environmental failures. Okay, so electrical failures, there will be a flashover. Like flashover occurs when the air surrounding the insulators become ionized, and it creates a conductive path that leads to an arc between the metal and fittings. So due to flashover, it contaminates the contaminants such as salt, dust, or industrial pollutants on the surface insulators, and there are high humidity of or rain which reduces the surface tension also. क्या हो रहा है यार? Okay, so the main effects of flashover are temporary loss of insulation leading to power outages and possible damage to insulators coatings. So the prevention that can use for not occurring the flashover is that we have to regular clean the insulators, especially in polluted areas, and we also apply the RTV silicon coatings for pollution resistance, and we can also install the arcing horns to divert over voltages. Now, B part is puncture failure. So, a puncture occurs when the insulator's dielectric material like ceramic, glass, or polymer breaks down internally and allowing current to pass through. So the main cause of puncture failure is that during the manufacturing process, defects like porosity or air gaps in the insulators, and if there are any high voltage stresses exceeding the dielectric strengths, and aging and water ingress in composite insulators, these all can cause the puncture failures. So due to the puncture failures, there are permanent damage of the insulators, risk of short circuit or and power outages. So we can conduct the puncture voltage test before installation, and can also use the high quality tested materials, and we can also apply water diffusion test for polymer insulators. Now, third is corona discharge and RIV, that is known as radio interference voltage. So, corona discharge is a localized ionization of air around high voltage conductors and insulators, so leading to energy loss and electromagnetic interference. So, because of sharp edges or improper design of insulator fittings, second is high humidity and atmospheric pressure changes. These all can cause the corona discharge. So the due to corona discharge, there is a degradation of polymer insulator materials, and also electromagnetic interference occur, which can affect the communication system. So to prevent this, we have to use the corona ring installation to distribute the electrical field stress equally, and we can use smooth surface design for insulators hardware, and also conduct RIV testing during manufacturing process. So now next failure is mechanical failures. Brittle First is brittle fracture. This is the for composite insulators. Brittle fracture is a sudden catastrophic failure in polymer insulators due to the mechanical stresses and environmental stresses. So brittle fracture it can be caused by stress, corrosion, cracking of fiberglass core, or acidic due to an exposure to the acidic pollutants like from industrial emissions and high mechanical loads over long periods. So brittle fracture can affect the complete failure of the insulators and leading to conductor collapse. So we can use the ECR. ECR is the E-glass corrosion resistant fiber coats in composite insulators, and also we can also conduct the water diffusion test to check the moisture absorption. Also we will apply the UV resistant coatings to prevent the aging effects. Now, second is mechanical overloading. So, insulators can break due to the excessive mechanical tension from conductor loads, wind, or ice accumulation. So, if there are any high tensions due to the strong winds, heavy snow, or icy storms, and if there are any improper installation angles leading to bending stress, aging and material fatigue. Due to all this, mechanical overloading can occur, and breaks the it insulators breakage, leading to the line collapse. So we can have to proper mechanical load testing before installation, and also can use the double or triple insulator strings for extra support, and regular visual inspection for cracks or if there are any stress marks. So C part is environmental and aging failures. So in environmental and aging failures, we see the UV degradation and weathering. So polymer insulators degrade their performance under prolonged UV radiation, leading to surface cracking and loss of hydrophobicity. So long-term exposure to sunlight, lack of UV resistant materials in polymer insulators, all can cause the UV degradation. So due to this, it reduces the insulation performance, also increases the leakage current due to the loss of hydrophobicity. So for this to prevent this, we have to use UV resistant silicon rubber coatings, and can conduct the accelerated aging test in laboratories. Now second is pollution induced failures. So contaminants accumulate on insulator surfaces, which creates a conductive paths or leakage currents because of salt deposits in coastal areas, industrial pollutants in urban zones, deserts, sand accumulation. So all this can affect the increased leakage current that leads to tracking and erosion, and there will be higher risk of flashovers and power outages. So we can use hydrophobic coatings like RTV silicon, and also regular cleaning schedule in pollutant regions, and self-cleaning insulators design. Now, moisture ingress and freezing failures. So, moisture penetration in that can it cracks can lead to freezing, causing material expansion and structural failure. And because of micro cracks in ceramic or polymer materials, freeze-thaw cycles in cold climates, and inadequate sealing of polymeric insulator housing. Due to this effect, mechanical breakdown occurs due to internal pressure and degradation of fiberglass cores in composite insulators. So main prevention for this is hydrophobic coatings is to prevent moisture absorption, and we can use hydrophobic RTV silicon rubber, and application of water diffusion test for polymer insulators. So there are some prevention strategies like design considerations. We have to use some high quality raw materials for ceramic glass composite, and implement stress relieving features like corona rings, arcing horns, and we have to apply the UV resistant and hydrophobic coatings. Now, second was testing and quality control. So we have to conduct a routine test for mechanical, electrical, and environmental resilience, and have to perform accelerated weathering tests to assess the long-term durability. We can also use high voltage withstand test to prevent early electrical failures. Now, third is installation and maintenance. We have to ensure the proper mechanical alignment to prevent stress concentration, and schedule regular cleaning and inspection in polluted regions. and use the leakage current monitoring to detect insulation degradation early. So in this presentation, the as we know that insulator testing is very important for preventing electrical failures. It ensures the mechanical strength and guaranteeing the reliability under extreme weather conditions. It helps in selecting insulators suitable for polluted environments and prevents leakage currents. So type test, routine test, acceptance test, and special test. These all tests verify the design, manufacturing quality, and long-term performance of insulators. So by identifying potential failures, modes, and applying preventive strategies, testing enhances insulator performance and reduces the risk of power outages and equipment damage and ensuring the safety and reliability of the power transmission networks. So based on this presentation and previous two, there are some objective questions. Would you like to solve? Okay. So first question is, what is the primary function of transmission insulators? Options are to store energy, B is to prevent leakage current, third is to support transmission lines and isolate conductors from the ground, fourth is to regulate the voltage level. Yes, Sudarshan, Dilkesh, anyone? What would be the answer? So the correct answer is to support transmission lines and isolate conductors from the ground. Okay. Next question is, so the answer is C. Okay, to support transmission lines and isolate conductors from the ground. Now the next question is, what material is commonly used in the manufacturing of modern transmission insulators? Option A
C.
is
Polymer.
okay. Option A is wood, B is glass, C is polymer, D is steel. Which option you are saying? B, C.
C. Polymer.
Okay, polymer is correct answer. Now the third question is, which of the following is a key characteristics of porcelain insulators? A, high mechanical strength and weather resistance, B, low thermal conductivity, C, transparent nature, D is very lightweight. Which option would be correct? Porcelain insulators. Key characteristics of porcelain insulators. So it's A, high mechanical strength and weather resistance. Okay, now fourth question is, which type of insulators is commonly used in high voltage transmission lines? A, pin type insulators, B, suspension type insulators, C, line post insulators, D, shackle insulators. Which type of insulators is commonly used in high voltage transmission lines? I discussed in last class. Dilkesh, what would be the answer? Okay, it's B, suspension insulators. Now, fifth question is, what is the primary cause of degradation in insulators over time? What is the primary cause of degradation in insulators over time? First is physical wear. B part is environmental pollution and weathering. C is electrical overloading. D is mechanical stress.
B.
B, environmental pollution and weathering, or D? Which one?
B.
Environmental pollution and weathering. It's the correct answer. Okay, next question is, what is the main advantage of polymer based transmission insulators over porcelain ones? A, better insulating properties at higher frequency. B, greater mechanical strength. C is reduced weight and better resistance to vandalism. D part is higher cost.
B. Greater mechanical strength.
No. Correct answer is reduced weight and better resistance to vandalism. Polymer insulators, the main advantage of polymer based insulators over porcelain. Porcelains are highly weighted insulators. Seventh question is, which test is commonly used to assess the electrical performance of transformer insulators? Electrical performance of transformer insulators. First is dielectric strength test. B is impact test. C is thermal endurance test. D is mechanical strength test. Okay, option A is correct. That is dielectric strength test for electrical performance of transformer insulators. Okay, so the in eighth question, in transformer insulators, what does the reliability factor mainly depend on? First is material choice and manufacturing process. B is transformer size. Third is color of insulators. Fourth is weight of the transformer. Both of you can give the answer. What does the reliability factor mainly depend on? I have cleared it in first class slide. Sudarshan God, sorry. Dilkesh Kumar,
A. Material choice and manufacturing process.
yes, correct answer. Main uh, factor at which the reliability factor depends on material choice and manufacturing process. Now the ninth question is, which of the following test is essential to verify the mechanical strength of the transformer insulators? Insulation resistance test, bending test, temperature rise test, and surface leakage test. Mechanical strength, which is essential to verify the mechanical strength.
Bending test.
Yes, it's a bending test which is used to verify the mechanical strength of transformer insulators. Answer B, option B is correct. Now, the 10th question is, what is the effect of surface contamination on transmission insulators? What is the effect of surface contamination on transmission insulators? First is reduced electrical resistance. B is increased mechanical strength. C is enhanced insulation properties. And D is decreased electrical resistance and increased leakage currents. Due to the surface contamination, what will increase or decrease?
D. Decreases.
De- Decreased electrical resistance and increased leakage currents. This one?
Yes, ma'am.
Okay, correct answer. Option D is correct. Now the 11th question is, how does corona discharge affect transmission insulators? First is it strengthens the insulator's insulating properties. B, it leads to erosion of insulator surface. C, it improves the insulator's ability to withstand high voltage. Fourth is it reduces the mechanical strength of insulators. How does this corona
D.
discharge? Hmm?
D.
D. D or B?
D or B. Maybe.
It's B. Option is B correct. It leads to erosion of the insulator surface. Because if corona occurs, then there is a contaminated air surrounding the conductors, surrounding the insulators, and insulators, there is a leakage current flows inside the insulators. That's why it leads to erosion of insulator surface. So 12th question is, what is one of the major challenge faced by transmission insulators in coastal areas? Answer A, option A, high frequency interference. B, salt contamination leading to leakage currents. C, extreme heat causing material degradation. And D is heavy snowfall and freezing.
B. Salt containment leakage to. Sorry. Salt containment leading to leakage current.
Yes, in mainly coastal areas, the major challenge faced by transmission insulators are salt contamination leading to leakage currents. Okay. Now, 13th question is, what is the purpose of testing transformer insulators under normal conditions? What is the purpose of testing transformer insulators? Option A is to ensure they perform well under fluctuating temperature ranges. B is to determine the weight capacity of the insulators. C is to measure their ability to withstand seismic activity. And D is to assess their optical transparency. Main purpose of testing the transformer insulators under thermal conditions. Okay, it's option A, because under thermal conditions we check the insulators whether they perform well under fluctuating temperature ranges or not. Okay. 14th question is, what is the common failure mode of transformer insulators? Option A is loss of dielectric strength due to aging. B is short circuit in the transformer winding. C is overheating of the insulating material. D is physical cracking due to excessive insulators.
A.
A. 14th. Loss of dielectric strength due to aging. Okay. Uh, okay. Done for today. Now, at the last turn, we will discuss the cleaning process of insulators and end of this subject. Okay, after that you will have to give an exam for certification from NPTEL. Till then, thank you so much for joining me. Okay, bye.